Okay, hello fellow developers. So today we'll talk about Java concurrency. If you have searched for this video, you probably know what concurrency is and what the thread is and the concept of multi-threading. So today I'm going to show you how to use such in Java. First, we can create a test case or a class. Let's just create a class that you're going to practice on. So we create a class. So let's name it concurrency test. So this is the class we are going to use for working with the Java concurrency. So in this class, we'll be having our main method here. And just a little bit for it to initialize. Yeah, we'll be having our main method here. So as you know, we first have to create a thread and a class that implements the runnable interface or an instance of the runnable interface. So you know you can implement the runnable interface using a class, or since the runnable interface is a functional interface, you can replace it with the lambda expression or any other expression you might use, but we'll work with the lambda expressions. So but I'll show you both ways, how to do it both ways. So let's start with the working with the concurrency. Let's start, okay. So a little bit, let's erase out. I'm sorry, my D is really slow. Yeah. So this is our class. We'll work with the lambda expression and then I'll show you how to work with the classes. So we first, there are multiple ways using which you can achieve such. So we'll print out a couple of lines. We'll create two instances of two threads, and each thread will print its own line. So we'll begin by instantiating or creating objects of the runnable interface, in which we'll pass them to different threads. So we can have, it's a runnable, can have one runnable object. Let's name it task. It's a task 1, which is, so you can create a new runnable and you subclass the run method, or you can just use a lambda expression. So first we'll use the lambda expression here. So in the lambda expression, it's where we'll, inside these brackets, we'll place the code that you want to run in a separate thread. So we can say here we want us to print out the standard to the standard output stream. So we can print out names like hello, my name is comma, and say okay, hello. You can say first hello, you can just print hello. Then we can have something like, okay, hello. Can have another string here, developers. Yeah, we can have such a string. So let's print out just the two strings there. Then we'll have another object, the runnable interface, or you can say an instance of it. We'll name it task2, which is, okay, first you've used the lambda expression, the other one, let's class the runnable, the run method of the runnable interface. And so we can create a new, so I can show a couple of ways. It's a new runnable, yeah, it's a new runnable, and you override it, you override the run method, of the runnable interface. So what it has done is you create a runnable. I am sure if you are looking for the concurrency right now, you know what I've done, which it's a syntax of creating an anonymous class, which in short, you are creating an anonymous class which implements the runnable interface, and we've overridden the run method. So inside this run method is where we place our code that you want to execute in a separate thread. So inside here, it's the same as this bracket. It's not the same, but essentially you are doing the same thing. Since it's a functional interface, you can replace it. A functional interface has only one method. So that method, you can implement it by using the lambda expression. So here you're just saying it's like, I've overridden the run method, and inside the run method, run this block of code on a separate thread. Here it's also doing the same thing. So we can place another lines of code there. So we can have a string like today, and just have today. Then we can have today. Then okay, you can say today, and it's a good day. So we can say today. You can have today. You can have a string like okay, it's good. It's a good day. Yeah. So I'm sorry, I can just do that. So hello, today it's a good day. So we have two runnables, or you can say two tasks that you want them to run in separate threads. Yeah. So we have right now we have 3 threads. Yeah. So we have the main thread of execution, which will execute the main method. Will run here. Then we'll have we typically don't have the threads yet. These are just tasks, the runnables. But okay, let's first create the threads so we can be accurate in what we're saying. So let's do this. So we have the runnables, the 2 of them, or you can say the tasks. So we create the threads for them. So we can have, it's a thread, and we say thread 1, which will execute the first task. We can say we create a new instance of a thread. It's a thread, yeah. Here we can have a new instance of a thread. So it's new. Can I have a new thread? So there are, as you probably know, the thread has a lot of overloaded constructors. So, but now we'll use the constructor, the better one, which you construct a thread and you pass in a runnable, or a functional runnable, or a lambda expression to express that. So we could typically just put this expression here, this lambda expression inside here. It will do the same thing, but for readability, and you can see what I'm doing, it's easier to do it this way. So here we've created a thread and we pass task 1 because it will execute task 1. Yeah. So it will we want it to execute the first task. Okay, the first task. Okay. Yeah. So here we created a thread. We have a thread 1, which will execute the first task in a separate thread. Then we have another thread, let's name it thread 2, which will execute the second task. Yeah, good. Now we have the two threads. So we have two threads. We have the first thread, the second thread, and the third thread is the main thread of execution, which will occur here, the one which will execute the main method. That's the main thread. So now we have three threads. These are custom-made threads, two of them, and the main thread. So the thread has a couple of methods which you can use. So if you just type, okay, let's see the methods thread. You can have, like, say, thread 1. Right now we have just created the methods. Yeah. Okay, we have created the methods right now. But now these methods are there's something called thread states. So right now, as you have created, they are we can say they are in the new state. The threads are in the new state. They are not yet runnable. So we have a couple of states. We have the new state. We have runnable state. We have a blocked state. We have the waiting state and the timed waiting state. Okay. So, but that will cover in our next lesson. For now, we can just create an instance of threads for quick introduction. Since it's introductory, we'll go to these details deeper on later lessons. So we have the two threads. So to begin our thread, or to initialize our thread, maybe we can say to start our thread, we call the start method of the thread class. You can say that, of thread object. So we start. We'll learn about join and the other methods later. So here we have started the first thread, and let's also start the second thread, which is the 2, and we started 2. Yeah. So now the two threads are in the runnable state, which means they can be run. We have started the thread. Then for you to show you that there is a third thread, which is the main thread of execution, we can also print out here, like, let's say, thank you. Okay, good. So we can execute now this class. The main method can execute the main method to see our results. So if we run it, so we see the output. Let's run it to see what the output will be like. I'm sorry for the timing text, so let's wait a little bit. So here is the output we got. Thank you. You see, it's not properly arranged as we place them, because they are run in separate threads, and they are run in alternatively, typically. So we can say the first thing which was executed is this one. This thank you string was printed out. So this was printed out as a result, because when you begin, when you run a class, you start the main thread of execution, which runs the main method here. Yeah. So the main method ran, initialized these things until it terminated. The main method terminated here. So when this string is printed, it means that the main method has terminated. So the main method has run and it has terminated, and print out the string thank you. So the main method has already terminated. Now this today is run on a separate thread, or not a process literally, but a separate thread. The separate thread printed hello. You see, it printed the separate, or it started with the second thread. It was executed, which is today. See, today, then it's a good day. Yeah. Then this thread was executed. It ended. So when it's a good day is printed, it means the second thread has terminated. Yeah. So it's a terminated. It's in a terminated state. Then we have another statement here, hello developers. So that means the second thread was the first thread was executed. So you can see it started the main thread of execution, ended it, and then it started going upwards. It executed the second thread and the first thread that we defined. Yeah, good. So if we simulate, let's say, delays or typical application of such, which will be using the threads as daemons, we can simulate a delay, maybe because there's like we can't say separate processes, but we can achieve some kind of multitasking. This where some task is running here uninterruptedly and another task is running parallel to that task. Yeah. So let's say here we implement the delays. Let's say, so that you can see, we delay this execution of the the system, that out the print line hello. We delay that execution for, let's say, 300 milliseconds. So to do that, we use the static method of the thread class, which is called sleep. With sleep, then you pass in the milliseconds. You can pass in other objects, but you can also do milliseconds. So let's delay it for, let's say, 500 for half a second. Yeah. And we can also we've delayed it for half a second, and the other one we can do it with so it takes a long millisecond for 300 milliseconds. Yeah. So this doesn't realize it yet. You can do that. The pattern, yeah. Let's find out if we have the interrupted exception. So if we do this, we need to catch the interrupted exception. We need to catch it or handle it in a way. So we'll have to, this whole block, we'll have to put it in a try catch, put it in a try. You have to put it in a try catch statement. Yeah. You have to put in a try catch. Then we catch the interrupted exception and we ignore it. Yeah. We just ignore it for now. Yeah. So we have that. Yeah. We've delayed the execution a little bit. We also, let's also delay this one for a couple of time. Yeah. So we can delay this too. Then try. Can do a try. No, sorry. Can do a try. Yeah. Now try catch here, and we catch the interrupted exception. We also ignore it. Yeah. So then we delay this. We sleep it for, let's say, 300 milliseconds to. And the last one can delay it for a second. For second. Yeah, then we can delay also this. But if we do this, you have to put it inside a try and catch too. So let's just do this, then we'll see our output and we'll compare it. So let's wait. So you see, we started executing the thank you statement and the main thread of execution terminated, and then we came to hello. So the second thread was it ran the first thread, which was hello. So while it was waiting for half a second, the other one was running, you see. So they are running concurrently. That's how you're saying they are running concurrently or parallel, which means it doesn't have to wait for this thread to finish for this to be executed. So you see the first statement was executed, and as it was waiting, the other one was running. So you can see hello, this today, executed today, and today as it was waiting, the other one was also executed. So this one was waiting for 500 milliseconds, this for 300. So it printed today, and as it was waiting for 300 milliseconds, this waited longer. So it printed it's a good day too. And as it was waiting for a second, now this one had waited enough, so it printed out developers. Yeah. So that's basically how you achieve multi-threading in Java. So as we recap, you first have instances of the runnable interface, which you can achieve such by implementing the lambda expression, like I've done here. The second way, you can create an instance of an anonymous class which implements the runnable interface and overrides the run method here. Yeah. Now the third way, you can have typically your own class. Let's say have another class here. We call it let's say just thread test. Yeah, so we can have this class. Since you wanted to implement this class, since you wanted to run a separate thread, we can implement the runnable interface here. So when you implement the runnable interface, you have to implement the method of the runnable interface here. So here we implement the method, which is the run method of the runnable interface. So here we've implemented the method, and in the method here we can say we want to run. So let's make it a typical class. Yeah. So here we can have the fields. Let's say private string, and let's call the variable the field. Let's call it name. So in typical use cases, and we can have a constructor for that. We can have a constructor and we have the name. Okay, so we have a constructor like a typical class. Yeah. So next, we can, in this run method, we can have let's not delay it, so we can print out we can print out okay, my name is, and you pass it the name. Yeah, and just do this. It's good practice to use this. name. Yeah, so it prints out the name of the current instance or the object of this thread test class. Yeah? Good. So we can have here in this the same concurrency test class, which has the main method. We can create also an instance of the thread test class, which is a thread test class. Let's call it task 3. Task 3. Remember, it's a typical class which create a new object of the thread, yeah, and you pass in the name. So let's say the name is John. Yeah, good. So this is runnable also. It's a class that implements the runnable interface. So it's the same as, not the same, but it typically implements what this and this implements. So we can have the tab thread here, thread, and you give it value. It's new. It's a new thread here, and you pass the task 3 here, which is a class that implements the runnable interface. So you can pass task 3 to it. Huh? Good. So also we can, let's execute it at the last. Then we do it's thread 3. We start it. Yeah. Good. So when we run this class right now, it's very free to build. So here is our result. So thank you. You see my name is John was executed here. So we see the first thread that was executed is the main thread of execution. Then it executed the first thread, which we named thread 1, hello here. Then today it executed, as the first thread was waiting for 500 milliseconds, it executed the second thread, which is thread 2, which contained task 2. Printed today. Now as it was waiting for today, it was waiting for 300 milliseconds. It also executed the third thread, which contained task 3, and task 3 was to print out the word my name is and the name John, which we passed it here. John. So the third thread executed this task. The task is here in the run method of the runnable interface, which this thread test implements. So thank you for watching this video, and if you have any question, you can place it in the comment and I will be glad to answer. Yeah, thank you.